Hello everyone. In today's lecture, we are going to discuss about the concept torque. Now, what is torque? Let me show you some examples, real life examples before going into deep detailed discussion. Now, as you can see over here, the mechanic is using the wrench and it is trying to loosen the screws, right? So, what is he trying to do over here? As you can see, the length of the wrench which he has been fixing on the screw, head of the screw, and he has been applying either downward force or upward force, right, either to tighten it or to loosen it. So, in that case he has to apply the downward force or upward force. Now, suppose this is the head of the screw, okay, and this is the length of the wrench where the force needs to be applied. So, either you will apply downward force or upward force, isn't it, right? So, when you do so, the screw, the head of the screw, at the head of the screw will either loosen up or tighten up, isn't it? So, when it does, the screw will have either inward motion or outward motion, out of the wheel or into the wheel, isn't it? So, I hope you are getting it what I am trying to say, right? So, over here you are applying linear force either downward or upward, but what is happening to the screw? It is moving inside or outside, isn't it? So, that is the thing. So, over here when a force, linear force is acted at some particular distance, perpendicular distance, okay, at the point of or the point which is fixed, that point will be having motion either inward or outward, that is which we call it as torque. So, torque is acted upon on a body, okay, when we apply the force at a particular distance or length from the fixed point. That is, now let me tell you one more example, then I hope you will be clear. In linear motion, when we applied the force, that is linear force, there was motion or there was accelerated motion, we used to say, that is F equals to ma, right? Now, in the previous lecture, that is in this particular topic, rotational motion, we have discussed about the relation, that is the equation of motion or comparison between the linear motion and rotational motion to find out the equation of motion. So, angular displacement, linear displacement, angular velocity, linear velocity, angular acceleration, linear acceleration, this the comparison we saw. So, similarly, in case of linear, in order to provide translational motion, force needs to be applied. So, in case of rotational motion, the moment of force needs to be applied, which we call it as torque. What is that? Torque. It is expressed or represented by tau, okay. This is a Greek letter which we use, it is expressed in the form of tau, and this is the symbol which is used, okay. So, in case of linear motion, we apply linear force F. In case of rotational motion, we apply torque. Just the similarity, just like our angular displacement, linear displacement, angular velocity, linear velocity, angular acceleration, linear acceleration. So, over here the force F is our linear force, which when applied on the body of mass m, there is an acceleration a, okay. But when the torque is applied on the body by applying a linear force, okay, there would be rotational motion in the body. Due to force F, there is linear motion, isn't it, linear motion. But due to torque, there would be rotational motion, okay. Due to torque, there would be rotational motion. I hope that is clear to you. So, what is torque? It is nothing but a moment of force. What is that? Moment of force, we call it moment of force. Moment of which force? Moment of linear force, okay. Moment of linear force which provides rotational motion to the body. So, in our example over here, the screw will be in rotational motion, okay. The screw will be in rotational motion either in clockwise direction or anti-clockwise direction, depending upon the direction of applied linear force. So, if the direction is downward, the screw will have clockwise motion. If it is the if the force applied is in the upward direction, then the screw will have anti-clockwise motion, that is rotational motion. I hope that is clear to you, right? Now let us go into detailed discussion about torque. As we have already discussed that torque is nothing but moment of force. So torque is the force which provides rotational motion to a body. Of course, there has to be one linear force which must be applied at some angle to the length of the body from the fixed point. So here is the example. As you can see, there is a wrench, there is a screw, right? So you apply force upward or downward, okay? So the screw is fixed, the position of the screw will be fixed, okay? Now you are applying the force either upward or downward at a particular length. As you can see, the length is given over here, right? So when we do so, when we apply the force at a particular length, okay, that is either upward or downward, the screw would be in rotational motion, either clockwise or anti-clockwise, depending upon the application or direction of application of force, linear force. So what is torque? Torque is a moment of force which is rotational force. Why do we call it rotational force? Because it provides rotational motion. So torque is nothing but, which we express torque tau, of course torque tau equals to product of the perpendicular distance, that is length, where we apply the linear force F from the fixed point or axis of rotation, okay, and F is the linear force which you applied at the particular point, that is at a length L or R, which is a perpendicular distance, okay. That is perpendicular. When I say perpendicular distance, it means the force and the length must be perpendicular to each other. If they are not, then we have to find out the perpendicular distance between the force, okay, and the fixed point or axis of rotation. I hope that is clear to you. So over here, as you can see, the R is a vector quantity which is a nothing but position vector, okay, position vector. F is nothing but linear force, okay, linear force, clear, linear force. Now, so if those two are vector quantities and we are expressing in terms of cross product or vector product, the product obtained is also a vector quantity. Now, as we have already discussed this in the previous topic, that what is a vector quantity or what is a cross product or vector product, that is the product obtained would be also a vector quantity, but that vector quantity's direction would be normal or perpendicular to the plane containing two vectors A and B, over here R and F. So if I show you over here, as you can see, the R, okay, that is the length from the fixed point, that is the axis of rotation of the screw, and the point of application of force. So if force and R both are perpendicular to each other, okay, as you can see, okay. So over here, if I extend R, it looks somewhat like this, okay. Extension can be given to show the direction only. So when we go for R cross F, the torque, so over here you have to use screw rule, okay, screw rule. That is, when you go for R cross F, which I have already taught to you in the previous lecture, that is how to find out the direction, go for A cross B, that is R cross F. When you go for R cross F, that is the torque direction which is out of the plane, okay, which is out of the plane. So in the vector form, we express it by writing tau equals to R cross F, where R is the perpendicular distance. As you can see, perpendicular, they are perpendicular, as you can see, they are perpendicular. So this is our R vector and this is our F. So R cross F would be nothing but torque. I hope you got that. And torque is nothing but moment of force, which we also call it as rotational force, and its SI unit is, as you can see, r cross f. R is nothing but length, distance or position vector, its unit is meter, and force, it's Newton. So, Newton meter. What is that? Newton meter. Okay. And what would be its dimensional formula? Dimensional formula would be, we express the dimensional formula in terms of basic units, that is mass, length and time. So, Newton means force, force nothing but mass into acceleration. So, we express it that as m1 L1 t minus 2 into L1. So, it becomes m1 L2 t minus 2. Okay. I hope you got that. Okay. So, m1 L2 t minus 2 is the dimensional formula for torque. So, basically what is torque? Torque is nothing but moment of force or rotational force which provides rotational motion to the body. Okay. When we apply the linear force F at some distance or length which is perpendicular from the axis of rotation. Over here, as you can see, the axis of rotation, this is the axis of rotation. Okay. The center of the screw, but it is passing like this, okay, perpendicular to the plane. I hope you got that, right? So, how to find out the direction? Using the same concept which you have learned in vector product, that if a plane contains two vectors A and B, so A cross B equals to C, and C is nothing but A cross B. Okay, the direction we have to find it in that way. So, over here torque R cross F. So, R cross F, the torque would be coming out of the plane. Okay. So, that was all about torque, and if we want to write it in the magnitude form, how does it look like? So, torque tau would be nothing but Rf sin theta. What is that? Rf sin theta. Okay, only magnitude, and direction normal to the plane containing R and F. Okay, direction would be normal to the plane containing R and F. I hope that is clear to you. Now, let us consider a few more examples based on torque. Now, here is the example, as you can see, which will give you more clarity. Okay. So, the thing over here, as you can see, so this is a wheel. Okay. This is the wheel, suppose, and this is the center of the wheel, and the axis of the wheel passes through center of it. So, when you apply force F, okay, the wheel will rotate, isn't it? For that, you need to apply force at a particular distance from the axis of rotation, otherwise you can't rotate it. Suppose if you apply force like this, okay, at this particular position, will there be rotation? No, because you are exactly applying at the center, isn't it? So, there would be no rotation, but here there would be rotation, right. So, that is the meaning of there should be a perpendicular distance between the application of force and the axis of rotation. So, as you can see, this is the radius, suppose R. Okay. So, the torque, as you can see, if I apply the vector product, okay, if this is the direction of the our perpendicular length, that is the position vector, okay, or we call it as radial vector over here, okay, radial vector or radial vector. Radial vector means its magnitude is radius, but direction is outward from the center to the circumference, okay, radial vector, or position vector also we can write sometimes, okay, but in this case, because this is a wheel, so it is a radial vector, and over here as you can see the force. So, R cross F, R cross F, so the torque is outward, outward of the plane, okay, outward of plane. So, over here the torque, so over here as we can see, the radial vector and the force both are perpendicular to each other, therefore, the angle between them, because we used to write tau equals to R cross F, isn't it, or we can write simply as Rf sin theta, Rf sin theta, isn't it, Rf sin theta. But what is theta in this case? Because that is the angle between the R and F, R and F angle is 90 degree. So simply it is R into F. Okay, simply it is R into F. But what if I apply the force at some angle? So suppose this is the wheel, suppose, okay, this is the center of the wheel. I apply the force, suppose, in this direction. Okay, I apply the force in this direction, suppose, and this is the point of application of force. So this is the radial vector, this is our radial vector, isn't it? So over here, this is the angle between radial vector and force. So in that case, what do we do here? So if I consider this one, that is the sine component, okay, or the vertical component of the force F, so this becomes F sine theta. This becomes F sine theta, isn't it? Or if this is theta, okay, if this is theta, if I take a perpendicular to this force, so this becomes 90 minus theta, isn't it? This becomes 90 minus theta. So if this is r vector and the angle between this direction and the r vector is 90 minus theta, so this would be r sine theta. So in both the cases, the force and the radial vector has to be perpendicular to each other. So either you consider this force F or this r sine theta, or you consider this r and this F sine theta. In both the cases, r and F sine theta, F and r sine theta, both are perpendicular to each other. That is the meaning. Okay. So either you can write it as r F sine theta, or simply I will write, so I will give you the clarity, either you write r sine theta F, or you write tau equals to r F sine theta. Both are correct. Okay, both are correct. That is, either the sine component of r must be perpendicular to F, or sine component of F must be perpendicular to r. So in both the cases, you get the same thing. Okay, I hope that is clear to you. And how to find out the direction? Just roll your right hand. Okay, roll your right hand, that is r cross F, and the direction of the thumb will give you the direction of torque. So torque is a moment of force, which is nothing but a rotational force, because that provides rotational motion. And for the torque to be applied, you need to apply linear force at some distance or perpendicular length from the axis of rotation, which is fixed. I hope it is clear to you, right? So that was all about torque. Now let me give you one more our daily life example, that is the door. So you know that door is attached or fixed at one end, isn't it? So this is the axis of rotation. This is the hinge of the door, about which the door rotates when it either inward or outward, isn't it? So you have to apply force on this particular door. So if you apply force at the hinge, will the door rotate? No. If you apply the force at some distance from the hinge, that is either inward or outward, that force makes the door rotate about the hinge, isn't it? Either this way or this way, isn't it? So what I am trying to say is, there has to be some perpendicular distance from the axis of rotation where you apply the force, so that you can provide the rotational motion to the object or any body which is fixed about at any one of its end. Correct? So that was all about our torque. I hope you understood. Thank you.